Hello, and welcome to my talk on adversarial learning for debiasing knowledge graph embeddings. My name is Bibek Paudel. I'm a postdoctoral research fellow at Stanford University, and this work was done together with my colleagues at ETH Zurich in Switzerland. So I'm going to talk about why we need to deal with the problem of debiasing knowledge graph embeddings and some of the results that we've achieved. It's part of an ongoing work, and I'll also briefly discuss what we're doing next. So biases are known to be problematic, especially those that relate to social biases, because they unfairly discriminate against certain groups of populations. For example, against minorities, disadvantaged groups, and so on. It has been shown in the case of text documents that the representations learned from the word embeddings, encode the biases that are present in the dataset themselves. In case of knowledge graphs, this has not been as extensively studied, so we take a step towards addressing this problem. Here we see an example knowledge graph. A knowledge graph is simply a graph with edges that are labeled and also directed. Here, the circular shapes represent the entities, and the entities are connected by relations, which are the labels on the edges that connect these entities. So for example, here we can see that there are different countries and information about these countries. For example, their population, their area, latitude, longitude, and so on. And each country is an instance of the entity country. So this is how a usual knowledge graph is structured. And since these knowledge graphs are created from free text documents and online corpuses like Wikipedia, they are very likely to encode biases from their data sources. So here we look at an example of how different occupations are represented in the knowledge base. We look at DBpedia, and we see that for several genders, for several occupations, there's a distinct skew in how the genders are represented. For occupations like politicians and scientists, the knowledge graph contains a lot many male instances. And for other occupations like writer and artists, the knowledge graph contains a lot many female instances. This could lead to biases in downstream applications, for example, for node classification or link prediction. And there have been a couple of other approaches that look at debiasing the information from knowledge graphs. They selectively remove nodes, or they selectively look at the edges and aim at debiasing through such relations. But it is not as effective, because even if you debias with respect to gender, the relation gender can be predicted from other relations because there is high collinearity in the dataset. So we take a different approach. We present an adversarial learning in which we have a filter part and a discriminator part. The filter part aims at predicting the sensitive, for example, the gender attribute, and the discriminator aims at removing this gender attribute from the embeddings. And we look at the effectiveness of our model. Here we can see that on the left-hand side are the prediction accuracies for nodes of different degrees and for different genders. And we can see that the accuracy is in general higher for male nodes than for female nodes. And also it is higher for high degree nodes than for low degree nodes. And on the right, we can see the result of our approach. Our approach is able to balance the embeddings. For example, for both genders, now the accuracy is almost similar, and it also does not depend on the degree of the node. We do this while achieving the general prediction accuracy in the task of link prediction. So I invite you to look at our paper for more details, and I'd be happy to take more questions and to discuss this in detail if there's any interest, and also for future work in this direction. Thank you.